All right, guys, chapter 9, section 3. We're going to talk today about hyperbolas. It's not a hyperbola, it's a hyperbola, okay? So look at what a hyperbola looks like. Everybody look. Shh. A hyperbola looks like two what? What does it look like? Two what? Two parabolas, right? Going in opposite directions. You're either going to have two parabola-looking things going up and down or left and right. If they're opening up and down, that's a vertical. If they're opening left and right, that is a horizontal. All right, look at what direction that they open towards. They open towards the what? Towards the focus. Same thing that we've been talking about. It opens towards the focus. All right, so let's look at these a little bit. These are called branches. The two like parabola-looking things, those are called the branches. Your values are still the same, guys. Think about where your center is. Your center's in the middle. So your A value is the distance from where? Center to vertices. A. Center to vertices. Exact same thing that it was for ellipses. Same thing. What is your B value? What's your B? Center to co-vertices. And then what's your C? Center to. All right. Remember, A and C are on the same axis. So center to foci. They're important. They are important. What you do need to remember, what is important, is the first variable you see is the axis, the graph is transversing. You guys are like, what? If x squared is first, which way are your branches opening? If x squared is first, what axis is x? Horizontal, left and right. So if your x squared is first, then it's opening left and right. If y squared is first, it's opening which way? Up and down. It's always the first. Now you don't have to look at where A is bigger. A is always going to be first. The reason why is, you'll see in a second, when you have the equation of a hyperbola, there's a minus sign in the middle, not a plus. So it's actually a little easier to remember because there's a plus. There's a minus. Do you see what I'm talking about here? Do you see how in a horizontal, the x squared is first? In a vertical, the y squared is first. That'll be like that every single time. The only difference between an ellipse and a hyperbola, look, is a sign in the middle. There's a minus sign in the middle. So what changes with your other, when you're trying to find c squared? It's just the exact opposite of the ellipse. But again, I'm giving you all of these formulas. But understand that whatever variable is first, that's the kind of hyperbola you're going to have. If x squared is first, it's going to open left and right. And if y squared is first, it's going to open up and down. It's okay. As soon as you left, I'm like, yeah, alive. No worries. No worries. All right. One new thing. Do you see the dotted lines in the middle? Those are called asymptotes. All right. You're going to have to write the equation of the asymptote. It's just a boundary, and we'll talk a little bit more about it in a second. But it's not super helpful to just look at it right now. Once we do a couple problems, then you guys will be all right. All right. The equation of the asymptote. A horizontal asymptote. How do you find the equation? All you're looking for is the slope. It's the b over the a. Horizontal is b over a. Vertical is a over b. You got to remember that. And again, we'll talk more about this once we have problems to do. It's not going to be bad, I promise. Horizontal is b over a, and vertical is a over b. So let's just do a couple. Let's just do a couple of examples. Again, how do we know this is going to be an ellipse or a hyperbola? What's the sign in the middle? A minus sign. So if it's a minus, it's a hyperbola. Again, you're going to be given all of the formulas, so you're not going to have to guess. But every time that we've done one of these, what does this need to be set equal to? Needs to be set equal to 1. It's not, so fix it. What do I divide everything by? Perfect, okay? Everything that we've been doing, guys, you're going to do the exact same thing. So this is going to become x squared over what? 4, right? You guys with me? Minus y squared over 16 equals 1. Now the difference, if this was a plus sign in the middle, you would tell me that it was a vertical ellipse because the bigger number was under the y squared. That's not the case. Whatever is first tells you what you're dealing with. Right away, you know that this is your a squared value. This is your b squared value. Where is your center? How do you know the center of this hyperbola? It's where? At 0, 0, because it's obviously not moving left or right. There's nothing there. So you already know now your a value. If a squared equals 4, what is your a value? Plus or minus 2. Good. If b squared equals 16, what is your b value? Plus or minus 4. Remind yourself, this is from the center to what? To vertices. How do you find c squared? Yep, c squared equals a squared plus b squared. Again, you're going to get all these formulas. So your c squared is 4 plus 16. So c squared is what? 20. So c is what? Square root of 20, which is plus minus 2 square root 5. Remember, that's to the foci, center to foci. So we've done absolutely nothing different. We found the stuff. I know what kind of a hyperbola am I dealing with. Is this a horizontal or a vertical? It is horizontal. Why is it horizontal? Because x is first. Okay, so let's just look at this. Let's get a quick little picture. I know that my center is right here at 0, 0. God bless you. Yeah.
Why is it regular Pythagorean theorem versus the
Because in an ellipse, the middle sign here is a plus. So your c squared is the c squared, a squared minus. And it's just the opposite with a hyperbola. So let's talk about where our vertices are. If you're asked to find the vertices, how do I find out my vertices? Okay, plug in the a, right? How far? I go 2 to the right and 2 to the left. Do you guys agree? Okay, so I have a vertex there and a vertex there. Now we're like, oh, where is our foci? Well, what am I adding and subtracting? 2 square root of 5, all right? Where is 2 square root of 5? Well, 2 square root of 4 would be about how much? If I said 2 times the square root of 4. What's the square root of 4? 2, and 2 times 2 is 4. So your foci is going to be a little bigger than 4 over here and a little over this way. You guys agree? All right, we're just figuring out. So do you notice where all the important stuff is? The important stuff is on the x-axis. We already knew it was the x-axis. So you're going to have branches. And before you can draw the branches, you need to tell me where the asymptote is, where it's going to get really close to but not touch. So the way that we find that out, what kind, go back to the slide before this, what kind of a hyperbola do I have? Is it vertical or horizontal? Okay, it's horizontal. So what is the equation of the asymptote? Okay, y equals plus minus b over a times x, right? The only thing you really need is the slope. It's that b over a. You're going to go from the center, because you're not moving anywhere, and you're going to go b over a. So what is your b value? 4 over what's your a value? 2. So your asymptote is at plus minus 2x. Y equals. All you're doing is going from the center, guys, and going up 1 and where? Over 1. I mean, up 2 over 1. Up 2 over 1. Down 2 over 1. Down 2. Oh, so there is your asymptote.
Did you get that from this?
Yep. and then up 2 over 1, up 2 over 1, down 2, and like this. And the reason that is important is because now you can see, oh, here's where my branches go. It opens towards the focus, right? Through the vertex, but it doesn't touch the asymptote.
Can you zoom in on that?
Can I do what?
Zoom in on.
Sure. So if you were asked on a test to identify the vertices, well, your vertices, you guys already found them. Your vertices were at 2, 0 and negative 2, 0, right? Your foci was at positive 2 root 5 comma 0, negative 2 root 5 comma 0, right? Your equation of your asymptote right here. You're finding the exact same thing for all of these guys. It's just a matter of saying, okay, what am I dealing with? Where am I moving from the origin? Left, right, up, down, that sort of thing. You just got to take a second to kind of digest with everything. It's not incredibly difficult, I promise. Talk to me.
Can you do the
No,
Are those U's or V's?
that's a V.
Oh, I meant the foci. 2 square root 5.
Comma 0.
Oh, it's a 0.
I just can't write.
So you don't need to add anything to the y. It's always the horizontal.
For this one. If it was vertical, then you would add and subtract to the y. Yep. All right, let's do the next one. Let's go through it again. All right, first of all, what's the problem? 9 equal to 1. So let's just go ahead and divide everything by, as my children would say, 1 hundo. I asked them, how'd you do on your spelling test? Hundo. I'm like, there you go. So I'm going to rewrite this as y squared over what number? 4. Perfect. Minus x squared over 25 equals 1. Now, you can tell me a lot of stuff. Is this a vertical or a horizontal hyperbola? It's a vertical. Why is it vertical? Because y is first. Good. Where is your center? At 0, 0. Eva just asked a good question. She said, we only added stuff to the x because it was horizontal, right? So this time we're going to add stuff to the what? To the y. Perfect. Very good. All right. I know that my a squared value is 4. So what is a? Plus minus 2. I know my b squared value is 25. So what is b? Plus minus 5. How do I find c? A squared plus b squared. Perfect. So 4 plus 25. C squared is 29. So your c value is plus minus square root of 29. If you had to approximate where plus minus root 29 is, it's a little bigger than what? Than 5. Good. And negative 5. All right, this is the exact same thing that we did with ellipses. Exact. So now let's just kind of figure out where everything is. All right, if I'm going to draw a quick little picture, my center, where is my center? At 0, 0. Okay, so your center's at 0, 0. My vertices. Where are my vertices? Up 2, right? And down 2. So I have a vertex here and here. I have 2 vertices. One is going to be at 0, 2, and the other one is going to be at 0, negative 2. Everybody agree? Okay. So let's find our foci. Where are our foci? Up 5-ish, right? Excuse me. 1, 2, 3, 4, 5. 2, 3, 4, 5. So a little more. So like there-ish. And there-ish. So your foci, you guys are going to tell me your foci is at 0, comma, square root 29 and 0, comma, negative square root 29. Everybody agree? Okay. Now what's important for us to draw our branches? I know I'm going up and down. That's fine. But I need to know where the boundary line is that they absolutely cannot touch. How do I find my asymptotes? Y equals plus minus what? A over bx. Good. We're at the center, so we're not moving anywhere. So I just have to take my a value, which is what? 2 over what? 5. And that's the line I'm going to draw. I'm going to go from the origin. And I'm going to go up 2 and over how many? 1, 2, 3, 4, 5. And then I'm going to go down 2 and over how many? Good. Same in the opposite direction. So something like this. And now when you draw your branches, guys, what direction do they go? Up and down, right? They're opening towards the focus and away from your asymptotes. That's it. The only thing that's going to change in a second here is the center. The center is going to move. So guess what? When the center moves, no big deal. When you have the equation of the asymptote, it's the exact same thing. All you're going to do is instead of going from the origin, you're going to go up 2 and over 5, whatever, from the center itself. How do we feel? It's not horrific. It's not bad. One more. I want to do one more example. All right, here we go. Look. Here we go. Exact same thing. Look, which one's first here? The x squared's first, that's why it's left and right. Here, y squared's first, that's why it's up and down. How did our equation of the asymptote change? Really not much, because the only thing that's going to matter is your b over a or your a over b. You can move from your center, right? This is my h and k, that's my center, so I don't really have to worry about making the equation into standard form and all that good stuff. It's totally fine. Everybody okay? Yes? All right, let's look at this one example, and then we'll finish up tomorrow. All right, we don't have to worry about anything right now because everything's set equal to what? 1, all right? So talk to me about my hyperbola. It's up and down. It is vertical. Again, explain to me. I know you guys already know this, but why is it vertical? Because y squared's first, all right? So I know my a squared value is how much? 9. And I know my b squared value is how much? 4. Good. So a is plus minus 3. B is plus minus 2. Perfect. Where is my center? Woo! Don't get fooled, guys. This is my h. This is my k. Where's my center? -3, comma what? -2. All right, so we moved a little bit. No big deal. You guys told me this was a vertical. Yes? You told me it was a vertical, so I'm going to go back to what Eva said. If this is vertical, when I'm moving, when I'm trying to find my vertices and my foci, what am I going to add and subtract to? What letter?
The y.
The y, because it's a vertical. So let's go ahead and find our c. What's my c value? C squared equals a squared plus what? Okay, so 9 plus 4, c squared is the square root of 13, correct? All right, so c is plus minus square root of 13. It's in between 3 and 4, right? So if mathematically you were asked to go ahead and find the vertices, okay, let's find the vertices. My vertices. I'm adding and subtracting what number? What's the distance from the center to the vertice? 3 to what letter? Okay, so plus minus 3 here. So my vertices are at -3, comma, what? 1 and -3, comma, -5. Okay, perfect. So let's go ahead and find our foci. Again, up and down, or left and right. Which way? Up, down, or left and right? Anybody? Are we moving up and down or left and right? Up and down. Okay, so we're going to add and subtract here the square root of 13. How are you going to write that, guys? It's -3, comma, -2 plus root 13. And then -3, comma, -2 minus the square root of 13. Do I need to know exactly where that is? No. But you should put your vertices on your graph, and then your foci should be either above or below them, right? Because it opens towards. That's all you really got to focus on. So let's go ahead and draw ourselves a little picture. All right, where's my center? -3, -2. All right, so we moved a little bit. No big deal. No big deal. Where, ladies and gents, are my vertices? -3, 1, so there. And where else? -3. Yeah. Just 1, 2, 3, 4, 5. Okay. So my foci, I don't need you guys to be perfect. It's going to be up here-ish and down here-ish. How do I know kind of where they are? Which way do your branches open? Towards the what? Towards the focus, towards the foci. So your branches are going to go through your vertex and open towards the foci. Now I need to figure out what the boundary line is that these are not going to touch. This is all you guys have to do. What kind of a hyperbola did we start off talking about? Vertical, right? So your equation of your asymptote is y equals, well, look at it. It changes a little bit. Got a question?
Wouldn't the bottom foci be above? Like, how is it below that vertice? Would you say between like 3 and 4?
No, it's -2 minus 3 or 4, yeah. Look back on the slide before. What's the equation of your asymptotes when it's not at the center? Okay, so y plus k equals plus minus what? A over b or b over a? A over b, okay. And then x minus h. You don't have to worry about, oh my gosh, I can't, this formula is so crazy. No, it's not. What are the h and the k? It's the center, correct? So all you're doing is going from the center, whatever this value is. What is your a and what is your b? A over b is what? So you're going to move plus minus 3 over 2 from the center. So from my center, I'm going to go up 3. 1, 2, 3, and over 2. Right? Yes or no, guys? Up 3 over 2. And I'm going to go down 3 over 2. And then I'm going to go up 3 and over 2 this way. Then I'm going to go down 3 and over 2 this way. And then it goes just like this. Obviously, it would be better if I had graph paper. And then draw your branches. You don't get caught up in, oh my gosh, I got to put in the H and the K. No, you don't. You just need to know whether it's B over A over B, and you just move from your center, not the origin. You move from your center. That's it. All right? You do not have to, don't get caught up on this and then trying to put it into slope intercept form or anything. Just understand that the H and the K is from your center. So you need to designate if you have A or B and where it goes. A over B or B over A. Hi. Questions? Are we okay?
Minus 3 over 2.
Where'd I get it from? Because the equation of your, you have a bathroom. The equation of your asymptote, since this is a vertical, you take the A value over the B. It's on the last slide. If it was horizontal, it would be B over A.
What did you do for the x minus h?
It's just the center. So from the center, I went up 3 over 2, down 3 over 2 in both directions to find your little boundary lines. You guys want me to do the next one? Just look at it. She's like, I said no. I'm ignoring you. I'm good at that. I have kids. Is this a horizontal or a vertical? Why? Because x is first. Perfect. It's a horizontal. What's your center? At +3, +2. Perfect. What's your a squared? 1. So a is plus minus what? 1. What's your b squared? So b is plus minus 3. Good. And then your c. How do we find c? C squared is a squared plus b squared. So 1 plus 9. C squared equals 10. So your C value is plus minus square root of 10. That means from the center, guys, to find my vertices and my foci, where am I moving? Left and right or up and down? I'm moving left and right. Why am I moving left and right? Because it's horizontal. So I'm going to add and subtract what to find my vertices? 1. To where? The x. So plus minus 1. So my vertices are at 4, 2, and what? 2, 2. There you go. All right. How do you find your foci? Add and subtract what? Square root of 10. To where? Perfect. So plus minus square root 10. So you're going to be at 3 plus the square root of 10, comma, 2, and 3 minus the square root of 10, comma 2. Again, square root of 10 is a little bigger than 9, right? So 3 plus 3 would be 6. 3 minus 3 would be 0. So you have a kind of an approximation of where you'd be. But if you were going to draw yourself a picture, all right, where's your center? Right 3, up 2. There's my center, okay. So where are your vertices? At 1, 2, 3, 4, and 2. And at 2, 2. Okay, kind of close together, no big deal. Your foci is going to be to the right and to the left, correct? And then how do you find your asymptote? What kind of a hyperbola do I have? Horizontal? So the equation of your asymptote is y minus what? Y minus k equals plus minus b over a. And then x minus h. But again, guys, you don't have to worry about plugging that in. All you have to know is the b and the a. Because from the center, you're going to move what direction? B over a. What would it be? 3 over 1, right? So you're going to go plus minus 3 over 1. So from the center, you're going to go up 3 over 1, down 3 over 1. It's not a very good picture, but it's going to be real close like this. And remember, your branches open through the vertex towards your foci. Any graph that you have to do, I will give you a graph that's actually printed on there, so it's not like crazy hard to read and stuff. But in truly, if you guys can identify what kind of hyperbola you're talking about, you can identify your A value and your B value. You can easily find C, and then you're just using the slope from the center to figure out where your asymptote lines are. All right?